Now children, today we will see numerical based on ionic product of water, which is Kw. You know it's a constant. Now let us see. Calculate the concentration of OH minus ions when H plus ion concentration is this much given to you. Now children, in the same formula when we have H and OH, there's only one formula, that Kw is equal to H plus and OH minus ion concentration in moles per liter, like this in the square brackets. Now you will say, okay, H plus is given to me. What about Kw? Try to recollect children. In the notes I gave you that the value of Kw, this Kw at 22 degrees Celsius is 1 into 10 to the power minus 14 moles per liter whole square. You will say, what do you mean by 22? Children, actually the normal room temperature which we take for common reactions or standard reactions, I'm not saying the standard temperature. That you know very well is 0 degrees Celsius or 273 K. I'm not saying that. I'm saying normal room temperature, which is assumed to be 25 degrees Celsius. Now children, what happens at 25 degrees Celsius? This value was slightly higher than 1. It was 1 point something into 10 to the power minus 14. So what happens during calculations, a standard value was used, and that was the same value which we had at 22 degrees Celsius, and that was taken as standard 1 into 10 to the power minus 14. You know very well, if temperature will increase, this value will increase. But at Kw at 22 degrees Celsius, which was very close to our normal room temperature, which is taken for granted as 25 degrees Celsius, this value was very close, not much of difference. Hence, for numerical purposes, for calculation purposes, this value of Kw was used. One thing. Second, this value, whether it is given to you or not, this value of Kw should be used if no other value is given. Clear? Suppose they give you some other value. Other value means the temperature is totally different. Say it is 100 degrees Celsius, or say it is 50 degrees Celsius, or it is say 5 degrees Celsius. That time the value will not be close to this. That time they will either give you the value. And suppose they are not giving you, then taken for granted the value of Kw is to be used this. That's why this point I should have not written while solving the numericals. It's only for your convenience to read. You should have written this point only. This Kw is this to be used. Rest this I wrote only to explain you so that you remember. So this value of Kw should be used if no other value is given. This is the standard value to be used. Again I am saying if no other value is given. Suppose they gave you the value of Kw as 2 into 10 to the power minus 12 or 1.8 into 10 to the power minus 14, 15, you don't know, 16, whatever. Then you have to use that value. But if at all no value of Kw is given to you at any temperature and you require in the formula to be used, you can take it for granted anywhere and everywhere for solving your numericals. I hope this point is clear to you. So if no other value of Kw is given to you, you can always take this value for calculation purpose. Now, so we know the formula Kw is equal to H plus and OH minus. So OH minus will be what? Kw upon H plus, like this. So Kw is this, H plus is given to us as this. So ultimately you calculate it and this is your answer. I took up this question that they might ask you calculate H plus or OH minus ion concentration. So it can be this way. Or it could have been H plus if OH minus was given, vice versa. So you can see the formula Kw, how to be used, and if at all the value of Kw is not given to you, how you will use this value. If no other value of Kw is given to you, you will use always this value. It's a constant. Maybe it is not given in the questions. So you are supposed to be knowing this value and use it for your calculations, solving the numericals. So for this video, it was a simple numerical, but I hope every point is clear. I've explained you. So for this video, we stop here.